Hi everyone, I am Abhishek. Today in this video I will discuss about LIS, or we can say that longest increasing subsequences. First I will discuss the approach about what is this subsequences and how we are going to pick this longest and what is this longest increasing subsequences. Then we'll discuss about the approach to solve this problem, and then we'll solve this problem on the LIT code. Thereafter we will discuss the time complexity, as well as I will give you one tip to improve the time complexity. First, this is going to be a brute force algorithm. We have another video for the optimized algorithm. Thereafter, I will give you the tip to optimize the time complexity. It will not be restricted on this problem only. It is going to be for all other problem which might be of this nature. Okay, so on that type of problem you can apply that and you would be able to solve that problem in reduced time complexity, whatever it was earlier. Thereafter I will show you some of the real life example of longest increasing subsequences, exactly where we use this. Okay, so without wasting any time, let's start this video. Okay, let me take one smallest example, then I will discuss about this increasing subsequences and what is this subsequences and how we are going to pick this longest one. Okay, so suppose it is 4, then 3, then 5, then take 2. Okay, fine. Now what I have to think of, what is this subsequence? Okay, so this subsequence is nothing but it's type of subarray, but this is some standard on this subarray. So at any instance I, if you are picking any element I, then you have to be make sure that this position I is going to be greater than all the position whatever it is in your till now subsequences. Okay, means at any element position should not be less than any other element which is already in there in the subsequences. What I mean to say is, see, I will take some example. 4, 3, suppose 8, then 6, suppose 4, 3, suppose then 2, 2, then 5. Is this 2 are subsequences? See, 4 it is fine, 3 it is fine, 8 it is fine. Till now every element is coming after 6, but it is coming before this element. Okay, but till now we have picked 8 also, so any element cannot be before this. Okay, it cannot be. If it is, then it is not a subsequences. In the same way, 4, 3 it is fine, then picked 2, so any element whatever it will come after this, but it is not, so it should be ended till here only, but it is 5, so it is not a subsequences. So till now it is not subsequences, so then what it is? So it will be 5, 4, 7, 8, 5, 2. This is a subsequence. Other formation also is possible, just I took one example. Okay, and we have to take the increasing one. Can you see it is increasing? 4 it is, 7 till now it is increasing, 8 till now it is increasing, 5 it is not increasing. Any element at any instance I, it should be greater than all the earlier element. Okay, but it is not, so it is not increasing. Okay, let's see what will the increasing one. Then we have 3, then we have 7, then we have 8, it is increasing. We have 3, we have 6, we have 8, it is increasing. 3, 5 it is increasing. Then we can say we have 4, we have, so let's say 3, then 6, then 8, only 3 elements only. Okay, fine, this is also right. So it is in the subsequences, these all are the subsequences and these all are the increasing. Now we have to pick the longest one. So it is of length 3, it is of length 3, it is of length 2. The one which we have to pick should be of greater length, so anyone from these two we can pick, but right now we are intentionally just to get the length, so anyone you pick having length of 3 only. So what would be the LIS for this? That is the length of LIS, that is going to be 3. I hope so this is clear to you. Let's take this example and we will try to understand what exactly we want to do. Okay, let's get here only. For now what I am going to tell you, suppose till 3 7, till 3 7, this is one subsequences. At any instance I want to add this 8. How can I think this would be a part of this existing subsequences, which is in itself increasing? I don't know it is longest or not, but right now it is increasing subsequences. Can I add this 8? It is asking. So if it is for sure that this e is something which is increasing subsequences, and if it is increasing subsequences means the last element will be always the maximum from all the element, right? It might be equal to some element but always be maximum or equal if it is same element. Suppose 3777, so last element will be some 7, it's fine, but in itself 7 is only the increasing maximum one, right? So if I can know, if I can ask from their maximum element, can I be part of your subsequences or not? If their maximum element is telling me yes or no, what will be the answer for yes? Means what we are going to do for yes. Suppose incoming element, like here it is 8, if it is greater than their maximum element, okay, we are having two answer, yes or no, right? Suppose if it is telling yes, then what I will tell, okay, if you are telling me yes, then I can be a part of your subsequences. Means whatever you were, suppose ln is the length of their already what I can say, their all existing subsequences, increase subsequence which is increasing, right? So I can say okay, I can be a part, so my length is 1, so just I will add one more in your length, and I will tell okay, I am the one who can be a part, so till me this is the length ln plus 1. So exactly what this representing, let me take this e of I. Suppose at any instance e of I, it is representing what it is representing, it's telling I am going to the LIS till index I, okay, till index I, this will be the LIS, okay. So it is telling okay, if it is incoming element, it is going to be accepted to be a part, so it will tell okay, that means whatever index I am, suppose I am the index j, then it will tell okay, then this is going to be e of j, right? This is what we can try, right? So this will be ln plus 1 will be their answer. It might be sometime already stored value might be greater than this, that we will while iterating we'll get to know. First just understand, if it is yes, then we are going to update their value, that's it. If it is no, then it will tell okay, if I cannot be part, then whatever value I was having, that I will be, whatever your value were, that you will be, that's not an issue, okay. So let's start with this example. We'll try to dry run this and then we'll understand it, okay. So let's take it here, and what we have thought, any for any existing, we are going to add one element. So can I tell okay, just think one more, can this itself a single value be a LIS or not? LIS or not? Just think on this. I mean to say, can I tell 4 in itself are increasing subsequences, 3 is odd in itself, 7 in itself, in the same way 6 8 5 2 in itself? Yeah, it is possible. 4 in itself will tell yeah, I am only single element which I can tell okay, it is increasing subsequences. In the same way all element of length 1 is increasing subsequences. So let's e, okay, let's take one space, okay. Now for e I can say yeah, I have of one length, so we are having 3 6 1 7 element, 3 3 6 1 7 element, okay. Now we will ask for 4. For 4 all the other element will ask, from 4 it will getting be asked by all the other element, can I be part of 4, this LIS 4 or not, okay. This is the length, I can say ELN or LIS, let's say this LIS, okay. So now I will tell okay, fine, I will be asking, this is what we are making existing, right? Existing subsequences which is increasing. So it is telling okay, 3 will be asking from 4, so it will tell okay, just tell me 3 is greater than 4. If it is yes, then you can, else no. If it is telling no, so no need to think of anything, just go forward. What is the index for this? Let's take this. Okay, it's fine, we can understand. We have each and every element a single here only. Okay, so for 7, it is greater than 4 or not? It is telling yes. If you, then 7 will be okay. I am of length 1 plus whatever it is length for 4, LIS length for 4. I will pick that and will update my value. Okay, just go for 4 and take the value. It is 1, so update this. It is 1 plus 1, that is equals to 2, correct? Right? So just go ahead and update 1, 2, 3, 4, 5, 6, 7. Sorry, this is going to 3, 3, 6, 1, 7. Yeah. So for 3, it is going to be updated. Not for 3, it's for 7, right? It's for 7. For this man, it is going to tell, okay, I have updated my value. Now we'll go and check for 6. Is 6 greater than 4? It is telling yes. So it will take 1 plus, what is the value for 4, right? Because we are trying to ask from 4. So asking from 4, so 6 is of length 1. And what is the value for 4? 4 is 1. So 1 plus 1, again it is 2. Let's go ahead and update the value for this one. In the same way, we are going to ask from 8. In the same way, we will be asking from 5. Okay, let's segregate. So it is telling yes. If it is yes, then 1 plus, what is the value for 4? That is again 1. So we are going to update for 8 also. Now we will see for 5. So what it is 5 greater than 4? It is asking. It will tell you yes, I am the one who is greater. So 1 for 5. What is value for 4? That is also 1. So it is going to be 2. So for this one, it's going to be 2. Now we'll ask for 2. Is it greater than 4? It's telling no, you are not. If you are not, then no need to update anything, right? So we are done with one element. Let's start with the next one. For this, what we are going to be this updated value. Okay, so now we will go for 3. We are done with 4. So for 3, it will tell okay. For 7, come. Now 7 will ask. So it is telling, okay, just tell me, is 7 greater than 3? It's telling yes. If it is, then it will tell okay, 1 plus, what is the value for 3? For 3, we are having again 1. So 1 plus 1, what will be the value? That is 2. So let's update this with 2. Now go ahead for 6. Is it greater than 3? It's telling yes. Now it will ask the same, just we will simulate this. For 6, is it greater than 3? Yes. For 8, is it greater than 3? Okay, let's segregate. It will make messy. Okay. So for 6, it is greater than, yeah, it's telling yes. Then what is the value for 6? That is in itself single value 1. Now don't get the value for this one. Okay, because we are just adding single element. Okay, so for single element we are having of length 1. Now we are going to tell okay, if it is till 3, then what is the value for till 3? So till 3 it is telling 2, right? Right now just we have updated, right? Okay, so till 3 we have updated. Okay, we did wrong, man, we did wrong. Okay, so actually we want to update at 7, right? Because this is not we are updating, this is we are going to update the value. So 7, for 7 it is earlier 2 only, so max of 2 comma 2 will be 2. So right now here for 6 is greater than 3, it is telling yes. So 1 plus 1, it is going to be again 2. So for 6 again it is 2. In the same way, what is for 8? Is it greater than 3 or not? It's telling yes. If it is, then 1 plus what? 1 plus what is the value for 3? Again it is 1. So let's update. It is 2. Again we are already having this. So what for 5? Is it greater than 3? It's telling yes. If it is, then 1 plus how much? For 3 we are having 1 only. So it is 2. This is already updated. The same way, is 2 greater than 3? It's telling no, that's fine. So no need to change anything. So till now we are having this update value. Let's go for 7, right? For 7 it is asking, now 6 is asking, can I be part? So it is telling, just tell me 6 is greater than 7, it's telling no. Now they're asking, okay, for 8, is 8 greater than 7? It is telling yes. If it is, then I'm going to tell, okay, for 8 it is length 1. Tell me what is the length for 7? It is 2. So it is 3. So now go for 8 and update with value of 3. Correct? It's 3. Means maximum of 2 comma 3. That is 3. Right? Because if anything which is already there a value, then why? If it is already greater value, whatever we can compute till now, so why I will update? Means just we have to take the maximum of what, that will be our answer. Correct? Now for 5, is greater than 7? 5 is greater than 7, it is telling no man, it's not like that. 2 is greater than 7, it's telling no. So that's it. Till now it is fine. We have this still updated value. Now what we will go for, we are going for 6, right? So for 6 it is 8. Who is going to ask, am I greater than 6? It is telling yes. If you are greater than, then 1 plus what is the value for 6? So it is 2. Correct? So that is 3. Now go ahead for 8 and update the value. It is already 3. So maximum 3 comma 3 is the same, no changes. For 5, is it greater than 6? It's telling no. For 2, is it greater than 6? It's telling no. Fine. So we have this updated value, which is same with the earlier, but we have this. Okay, let's go for the next one. What we will go for? We are now go for 8. So now this 5 is asking, am I greater than, can I be part? It's telling me 5 is greater than 8. No. Now it's 2. Is it greater than 8? It's telling no. So it also cannot be. In the same way, let's, here only we can go ahead for 5. So it is asking 2, can I be part? It's telling okay, tell me 2 is greater than 5. It's telling no, so cannot be changed. The same way we can go for 2, but that don't make sense because this is the last element. So till now this is the updated value. What I told you, that LIS of in the first page, let's see, I told you just it is going to represent till index I, what will be the length of this LIS. Okay, length of this LIS. Okay, so let's compute this. Till 4 it is one length, it's fine. Till 3, can we take any increasing subsequences which can be added 3 also? No, in 4 we cannot add, so in itself single element. Till 7, either it is 3 7 or either it is 4 7, right? So of length 2. For 6, either it is 3 6 or either it is 4 6, correct? So it is 2. For 8, either it is 6 8 or 7 8 or either 6 3 6 8 or 4 6 8 or 4 7 8. So only 3 length till 8. For 5, I can add 4 5 or 4 3 5 we cannot add. So 3 5 we can add. Okay, it is fine. From 7 we cannot, 6 cannot. Means these 3 cannot be part for 8 if we are trying, because these 3 guys are greater. Obviously that will not be. It is not increasing. So either any one element from these 2. So either 4 5 or 3 5. So 2 elements only. For 2, all the elements are greater, so it is only single element. So we can say, yeah, we have optimized it. Means we are able to get the LIS for each and every element. So this is the thing which we will be utilizing. Okay. So now first I told, like, I will be telling you some real life example. Okay, I have, we can see for any 2 files in version control, for any 2 files, like suppose there is one working copy, there is one which you have checked out, that is the where you haven't make any changes, right? So in that cases, like suppose one revision copy, second one is your working copy. Okay, so in that, suppose one of file you have made the changes, now you want to see the difference. At that time the algorithm which is being used in the diff, that is nothing but it is being utilized this LIS. one of the version control that is with the name of bazaar, they have used this is being utilized this algorithm LIS. Okay, there's two more thing I will tell you. This file comparison that I told, in the same way there is one real uh, software which have used this. This is the version control software that like Git or SVN. They have used this file comparison which is being implemented in LIS. Okay, so now let's solve the problem on the lit code. So we will solve this problem with this brute force whatever we have discussed. Let's declare first what will be the length. Let's calculate the length. This is going to be the length for what? For the nums. Okay, so we are going to declare it for whole ln, right? Now what we have discussed, that for each and every element we will be asking, right? For 8, 6, 7, 3, 4, for all the element we have, right? So this is the loop which is going to take care of that. We are going to pick one element, and for each and every element we will ask, tell me can be a part or not. So as we are going to ask from the next element only, so till last element. Okay, so what I will tell, okay, just I'm asking, can I add this jth element in your existing subsequences or longest increasing subsequences till your length I. Okay, can I add? So just I'm asking, it is telling, okay, tell me, are you the one who is greater than or equal to nums of I. See why we are using this equals to. As I told, it might be some like it is telling if you are getting element increasing only. If it is strictly increasing, then only equal to. This question is telling strictly increasing, so we cannot use this equal to. If it is not strictly increasing, then might be equal elements also. Okay, but here it is not the case, so it is asking, tell me, are you the one who is greater than me? If that is the case, then I can tell, okay, you can go ahead and take the answer. So it will tell, okay, fine, then LIS of what, whoever is asking, their value is going to be updated. So this is what it would be, the maximum of whatever I was having till now, right? Now what I will tell, okay, whatever you are having and plus me, my length, right? This is what I will take. Till now it's fine. So in nums vector I have this, sorry, not in nums, in this LIS we are having our maximum stored value till index I. So we are trying to return their maximum value. So what is the function for getting? This is the function that will help to extract the maximum value which is available in LIS. Okay, so we are going to extract the whole vector and we will get the value. Okay, that's it. I hope so this will work. And one more thing we are missing. See, okay, it is telling as we know, for each and every element, each and every single element is in itself a increasing subsequences. So for each element we have to start with 1, else this vector by default it will put a value of 0. So let's see what we are getting. Yeah, we are able to pass. So let's submit this. Yeah, we're able to. So what is the time complexity for this algorithm? The time complexity, what would be? See, the time complexity, what we are doing, we are picking any one element at index I, right? We are picking any one element for index I, which is going to asking and now this ln element are going to ask, this is asking from I, can I be part or not? So this is the length, or I can say j, right, that we are asking. So ln element is asking from I, each element of I. So this is also of length ln, right? So we can say total computation that we have queried for I into j, total number of I into total number of j, that is nothing but ln into ln, correct? Which is nothing but a quadratic. So what will be the time complexity? Time complexity is in the quadratic nature. We can say it is of nature n into n or n square. For this point we have discussed in ln. So that is nothing but the quadratic. So in itself it's not that much optimized algorithm. We have to optimize this. For that I told you I will give you one tip which will help you to solve this problem. Yes, I have. So let's see what I have. So I have one, or you can say tip or trick. See, if any type of problem you can see for strictly increasing, that you saw in the problem statement, right? Strictly increasing or decreasing, or only increasing or decreasing, or any constant, means this is the order that any array is going to follow. All the element of the array, either it is strictly increasing or either it is strictly decreasing, or only increasing or decreasing, or all the value are constant. If this is the nature, then you can think of linear search, sorry, binary search. You can think of this might be, not might, it will be utilized there. So you have to just first think of brute force, then apply this binary search somehow. If you are able to think of their solution in the binary search, means there will be a way, okay, we have to go toward binary search thinking for optimizing this problem is also going to be utilized with the help of binary search. This will be, their time complexity will be improved. Okay, so we will see that how we can do that. So I have done another video where we have discussed about the binary search approach of this longest increasing subsequences, that I told you as a tips here, right? So for any problem, it is not for this one, it is for the generic. You can utilize this if you are going to see this type of property for any problem statement, and you go ahead, use the binary search on your brute force approach, that will work. Thanks for watching the video. That's it from my side. We'll meet in the next video. Bye bye, tata.